Welcome to lab exercise number 3, torsion. The goal of this lab is to evaluate the equations of angular displacement, shear stress, and shear strain for a shaft undergoing torsional stress. Now let's talk about the principles. Torsion testing of round circular samples is another method of determining a basic engineering relationship in structural materials. The angle of twist is measured on a specimen as an applied torque is increased at a constant rate. Data collected from a torque versus angle of twist experiment can be used to develop a graph of torsional stress versus strain. As in a tensile test, there will be a linear portion of the curve where a proportional relationship can be used to determine engineering values. In a torsional stress versus strain graph, the value that will be determined by measuring the slope of linear region is the modulus of rigidity, often given the symbol G. Experimental values of angle of twist can be compared with expected calculations based on the applied torque and certain material properties and geometry.
Now for the materials, we will be using a 3/16 inch diameter of the following metal rods: 1018 steel rod, 6061 T6 aluminum rod, and 360 brass rod. Take the following precautions. Weights will be used on hangers to create an external force on the rods. For safety, we will use caution when loading the weights. Do not use broken strings as they may cause the weights to fall. Beware of unbalanced loading, and also do not keep feet or hands underneath the area the weights are placed. Be cautious of all areas which may cause damage.
For this pre-lab, we will use SI units. Please remain consistent with measurements to create accurate results. Convert the diameter of the rods from inches to millimeters and calculate the polar moment of inertia, J, in millimeters. Calculate the expected value of twist angle in degrees per Newton millimeter of torque for aluminum, brass, and steel. Remember that we are using SI units for this lab, so convert the shear modulus to units of newtons and millimeters. Assume a length of 200 millimeters and 400 millimeters for all three materials. Now for the procedure. There are two profiled ends to each specimen, a semicircular end and a triangular end. The triangular end is to be clamped in the jaws of the chuck, while the semicircular end is to be clamped in the fixed clamp at the other end of the base plate. Make sure to clamp the triangular end first into the jaws of the chuck. Clamp the aluminum alloy specimen in position and put the load hanger on the cord. Set the pointer to be 400 millimeters from the fixed end and bring the rotation scale close to the pointer. Zero the pointer. Add a load from 5 newtons to 60 newtons in 5 newton increments, recording the twist of the specimen for each increment on your data sheet. Remove the load. Move the rotation scale and pointer to 200 millimeters from the clamp, and repeat the above procedure. Measure and record the diameter of the rod. Now, change the specimen for the steel and brass rod and repeat the procedure with the pointer at 400 millimeter only.
And now that you have completed your lab procedure, you can refer to the lab handouts in order to finish your discussion items for your report.